So this will be part 2 of solving trig equations. Very anticlimactic there. Let's try this. There we go. So why might this one be harder than some of the ones we did yesterday? Because it's part 2. Yes, part 2 is normally harder. We have to factor, or we have 2 of them. We have a cosine squared and a cosine, right? They can't factor? Quadratic formula? All right, so you're absolutely right with the quadratic formula. Just making sure on that. So what was that quadratic formula again? You guys just said. You guys can. All right, so we have to have that down. What in this case is my b? Okay, but since I'm actually before I was just solving for x, this time I'm just solving for cosine x, right? So what would be my coefficient in front of the cosine theta or x this time? A 3, right? So I get negative 3. Plus or minus square root. What's b squared? 9. What's 4 times a? 1. 4 times 1 is 4. Times c. Negative 1. 4 times negative 1. Negative 4. Yeah, so I'll be subtracting off the negative 4. Same as adding a 4. All over 2a. All over 2. So square root of 13 over 2. And keep in mind, this is what cosine x is equal to. So can everybody find this negative 3 plus square root of 13 over 2 on your unit circle? No, it's not there, right? So what did we do yesterday when we went on our unit circle? We use a calculator, okay? So let's have these 3 tables right here. You guys have cosine inverse. I want you guys to do the positive side of this. All right, over here, these 2 tables, you guys take the negative side. Okay, let's talk about the positive one first. All right, now first of all, if I take cosine of something that's positive, what quadrants should I get answers from? First and 4, right? I agree. Okay, so what answer did I get on the positive? What is it? 0.3027. Is that in radians? Okay, so okay. Anybody else verify that? Brock did? No one at this table did? You said positive. I got that. Interesting. Take cosine inverse of it. Yeah. Did you take cosine inverse of it? Take cosine inverse of it. And so it gave me what, Jaden? Okay. 1 point what? 1.26. Well, how do I get this angle in the 4th quadrant? Add pi, that'd be in the 3rd quadrant. Let's think about this. It gave me 1.26. Let's just say it's about right here. If this angle is 1.26, I want to go that same distance from this axis right here into the 4th quadrant. So how do I get that? This is 2 pi, right? 6.28. Just subtract off this 1.26, and it'll tell me that 4th quadrant answer. I don't know what that is. Really? 5.02? We can definitely look at that. Hold on just a second. Just a second. So the negative is going to be defined in which quadrant? Oh, wait, did this give me a negative value? It gave you domain error. What was negative 3 minus the square root of 13? Negative 3.30. Then did you divide that by 2? This whole thing gave me negative 3.30. So you took cosine inverse of that? Okay, so you got cosine x equals this. And then you took cosine inverse of this. It's domain error. Why? Remember when we graph cosine, what did the values always stay between? 1 and negative 1, right? 1 and negative 1. When we graph cosine, we started at 1, we came down to negative 1. We went 1 and negative 1. Anytime I'm taking cosine or sine of something, these values right here, all those values on my unit circle are all between negative 1 and positive 1. Okay, that's why we got domain error. So this would actually be my only answers on this. Think of it this way: whenever we graph cosine, and then if I'm taking the inverse of that, that just means everything has to still be between negative 1 and 1. This right here. So these are the actual radian measures. It's like 72 degrees. And so whenever I added the plus right here, it gave me something between negative 1 and 1. That first number you gave me. So that means I can take cosine inverse of it. I can take cosine or sine inverse of anything between negative 1 and 1. Victoria, what was your question? Yeah, anyone. If you throw a degree, I'll have it on my key both ways. If you put a degree sign on there, I'll think you mean degrees. If not, I'll assume radians. Yep. Well, that's coming out of the gate strong, right? So our goal is to get something that's factorable so we can avoid that quadratic formula. If not, we'll just have to work with it. All right. So what about this one? Is this one going to be factorable? Did you? I think it's factorable. Now, if you don't, if you didn't see that as factorable, then yes, quadratic formula will still work, of course. But I always go to factoring first because that is gonna be easier. Take out a sign. This 3 doesn't have a sign to give.
No. Okay. It will be 2 minus. I know, right?
Would this be easier to solve?
No, it's the same thing.
It's the same thing, right? So how would I break apart this 2x squared? I would do 2x and an x, right? So I'm going to do the same thing with this 2 sine squared. I'm going to break it apart as a 2 sine theta and a sine theta. Just like I'm always solving for x in algebra, on these I want to solve for sine or cosine or whatever. Okay, from here I have the good old DHS plug and chug. Not plug and chug, guess and check. Plug and chug, nothing to plug into. So I'm looking for factors of positive 3, but keep in mind they're going to add up to give me something negative.
You're 1 in the first
one. 1 here, okay.
No, it's plus 1, right? No, it's negative.
So negative 3 goes here. And negative 1?
No.
Positive 1. Positive. Audrey. Whoa. Negative 3 and negative 1 will give me a positive 3. If I make one of them so they're negative 1, so it's positive, that'll give me a negative 1 or a negative 3. So I think this will work. Here's how we remember we did. That was my guess. Let's try it. Let's do the check. Let's check the nose. Let's check the nose. -3 sine. Let's check the mouth. -2 sine. What's -3 sine and -2 sine? -5 sine. So I had a good guess. All right. Notice there was two parts to the guess and check. The guess and the check. Freshmen are having trouble with that right now. So that means, thanks to my zero product formula or product property, that either this has to equal 0 or sine theta minus 1 is going to equal 0. Yes, they can both be. But one or the other has to equal 0. So if I solve this for sine, I'm going to add 3, divide by 2. Solving this for sine, I get 1. Well, where's sine theta equal to 1 at? Pi over 2, right? And if it's on the interval, that's fine. Or if it's not on the interval, what was the homework? Was it all on the interval? 0 to 2 pi? Okay, so we'll just leave it like that, pi over 2. Now, where is sine equal to 3/2? In your calculator, okay, go ahead. Because 3/2 is not on my unit circle. Just talked about this. Why did I get a domain error? It's not between 1 and -1. I cannot take sine inverse of something that's not between -1 and 1. So I'm not going to get any solutions from this. My only solution is going to be pi over 2. That's true. That's the only one. And you can definitely take this over and plug this back in and see if it works. You can check your answer with the original problem. If I take sine of pi over 2, what does that give me? 1 squared is 1 times 2, 2. Okay. Sine of pi over 2, you said was 1. 1 times -5 plus 3. Yeah, I gave me 0. So I can check it just like I check my algebra solving problems. Brees. So is it only for sine that being 1 or sine and cosine? Remember, it's a snake on a plane, so it'll be anything infinity, positive. Ooh. I can just change sine squared into cosine squared? How are you getting that? Trig identities. Why am I having to suddenly resort to trig identities on this one? Yeah, I'd like to have everything in terms of sine or everything in terms of cosine. I don't want sine and cosine roaming on the same problem. So you said to do what now? Okay, so I'm gonna call it 1 minus cosine squared. Is that okay? All right, you and your pod buddies, you guys take it from here. See if you get something that's factorable. If not, you're gonna have to resort to quadratic formula. Or you could complete the square, I guess. All right, so everybody gets pi on this one, right? Good. Are we done? Oh, we got one more. Subtract the 1. So the theme today, everything we've seen on here has been squared, and we're trying to factor it so we can avoid that first problem where we had to do quadratic formula. So does this one factor? I can take a sign out. Yeah, what is in common in both of these factors on the left side? Sine of theta. And this is what's throwing my freshman off. If you pull out a GCF, that is factored. It might not be factored completely, but in this case, it is factored and factored completely. There's no more squareds in there. So that means that either sine theta is going to equal 0, or 2 sine theta plus 1 is going to equal 0. Where's sine theta equal to 0 at? 0 or 2 pi. What time we just put 0? And pi, yeah. Yeah, sine of pi is 0. Over here, I've got a little bit of work to do. I need to subtract 1 from both sides. I'll make it negative and then divide by 2. Where is sine theta equal to negative 1/2 f? Okay, so we have 2 answers. Now, absolutely, we're going to have third and fourth quadrant. So pi over 6 is my reference angle. So what has pi over 6 in the third quadrant? 7 pi over 6. What has pi over 6 in the fourth quadrant? 11 pi over 6. Those are my 2 answers. Make sense? And the 0 and pi. I do have 4 answers on this one. Mm-hmm. Or pre-calc A. We did do factoring and all this in pre-calc A. We're done. Sweet. So I still don't think there's very many. 4, 5, 6, 7 problems. So get those done and have questions on the board for me or something from inverses still. Spend the rest of the time working on that.